Hello everyone, welcome back to my channel once again. So first of all, I want to apologize for posting this video by very much delay. Okay, I have some issues with the devices, that's why I could not make the video. But yes, we will do video every day. So where I stopped, I just stopped here that we have started carbon and its compounds. Okay, it is funny, right? Just a minute, let me do this proper, right? Okay, so we have already learned about what that carbon compounds. Okay, carbon compounds shows, yes, they shows low melting point and boiling point, and also they shows, yes, they shows poor conductivity towards electricity. Okay, why this is because we know that about ionic compounds. What we know about ionic compounds? Okay, we know that they have forces of attractions, right? Forces of attraction between the ions. Okay, between the ions, which is very strong. Okay, which is very strong. But in case of carbon compounds, it is weak. Okay, in case of carbon compound, it is weak. That's why they shows poor electricity, poor conductivity towards electricity. Okay, so since these compounds are largely non-conductors of electricity, we can conclude that the bonding in these compounds does not give rise to any ions. So carbon compounds, we can write carbon compounds are not ionic compounds. Okay, this sentence is very important, right? You can make it a star. Carbon compounds are not ionic compounds. Then what are they? What is their identity, right? So let's find out. So you have already learnt about ninth standard. Yes, everything is linked with the ninth standard. That's why you have to read your ninth standard textbook if you have every day, which is related to this carbon. Okay, carbon topic, you can read that, right? So meanwhile, if you are new for this channel, if you just watching a video today first time, just subscribe my channel for more such videos. Okay, so let's continue. We already learned about combining capacity of various elements and how voltage depends upon the number of what? Number of valence electrons. Number of valence electrons. Okay, what is valence electrons now? We already know, but still we are discussing this, right? Valence electron means, we'll understand with the one example. Okay, we have here example carbon. As we are talking about it, then that will be our guest only, so we have to talk with about carbon only, right? So let's look at the electronic configuration of carbon. Electronic configuration of carbon. Okay, so for that we should know what? Atomic number. Atomic number of carbon is what? It is 6. Okay, it is 6. So what would be the distribution of electrons in various shells of carbon? Now again new topic. What is it? Shells. Okay, in my one of my earlier video I have just told about the shells are there. How many? 4 shells are there: K, L, M and N, and we have to distribute the electrons in these shells. We have to give the electrons according to their capacity. Okay, according to their capacity we have to share the electrons. We have to put electrons in these 4 shells. Okay, if you draw the carbon's structure, okay, this is a nucleus of carbon which has proton and neutron, right? And this is one of its orbit. So as we know, atomic number is how much? 6. So it can be write as 2 and 4. Okay, so if you draw the electrons here, 2 will be here. Okay, and remaining, how many are remaining? 4. So they will go here. 1, 2, 3 and 4. Okay, so in this way you can draw the electronic structure of the carbon, and these are having how many? 6 protons. Okay, next, so how many valence electrons will carbon have, right? How many valence electron will carbon have? So as we know, in the outer shell, this is outermost shell of the carbon, outermost shell of the carbon. So we know the definition of valence electron means how many electrons are present in outermost shell, that will be their valence electrons. So how many are there? 4 electrons are there. 4 electrons which are showing the carbon's valence electrons. So we know that the reactivity of elements is explained as their tendency to attain a completely filled outer shell. So when you observe this, it is not completely filled, because what completely filled means, it should be attain a noble gas, okay, which is near to it, noble gas configuration. Noble gas means which has the 8 electron in its outermost shell, right? 8 electrons. But in the case of carbon, we have only 4 electrons in the outermost shell. So how many electrons are lacking here? 4 electrons. Okay, 4 electrons are lacking here. So elements forming, we know that, okay, when such type of conditions, we know that what other elements are doing, like sodium and chlorine, they are just sharing the electrons, right, or the ions. That's why we say them ionic compounds. So elements forming ionic compounds achieve this by either gaining or losing electrons. We know that from their outermost shell, and we have the best example, that is Na plus Cl minus, right? Then, so in case of carbon, it has 4 electrons in its outermost shell and it needs to gain. Okay, there are two situations are there. First situation is gain 4 electrons, or second will be lose 4 electrons. Lose 4 electrons. So let's see one by one what happen if it gain 4 electrons. So if it carbon could gain 4 electrons by forming, okay, we know when you are getting the electrons, you are having the plus sign, so it will become negative sign, sorry, so it will become carbon plus minus 4, okay, and this could be anion, okay, this could be anion. But it would be difficult for nucleus with 6 protons to hold on to 10 electrons. Means, again go to this structure, we have here how many outermost, in the outermost shell 4 electrons, and just I told you in the nucleus proton and neutron is present. Okay, so proton has how many? Proton has 6 protons are there. So in the nucleus only 6 protons are there. So how it can be balanced with the 10 electrons in the outermost shell, right? Because if you gain 4 more electrons, so total it will become extra how many? 4 electrons it will become. So togetherly how many it is? 10 electrons. 6 plus 4, 10. So it would be difficult for the nucleus with 6 protons to hold on to 10 electrons total, that is 4 extra electrons. So this will be not happen. Now let's check out the second situation. When carbon loses 4 electrons, it will become cation, that is C plus 4 cation. Okay, again, but it would require a large amount of energy to lose these electrons, to remove 4 electrons, leaving behind only 6 protons. Okay, only 6 protons in its nucleus, holding on to only 2 electrons are there. We know here in the first shell it has 2 electrons. So if it loses this outermost 4 electrons, again it is very hard to this nucleus of the carbon that to manage with the only 2 electrons. So this is also not possible. So what will be the option for it? That's why we have this problem here, that carbon does not involve, okay, Carbon does not involve in gaining or sharing, gaining or losing, not sharing, losing electrons. Okay, you must have guessed about it. So here, what is the remaining? Yes. So carbon will share the electrons. Okay, carbon will share the electrons. Sharing is caring, right? So carbon overcomes this problem by sharing its valence electrons with other atoms of either it will be carbon or any other atom. Okay, other elements atom. So not just carbon but many other elements form molecules by sharing electrons in this manner. So the shared electron belong to outer shell of the both of the atoms and lead to both atoms attaining the noble gas configuration. Before going on to carbon compounds, let us look out some example. Okay, before going to the carbon, let's have the example of hydrogen. Okay, so hydrogen hydrogen has atomic number 1. Okay, and hence hydrogen has only one, so it will show in the K shell, it will show the 1 electron. Okay, and how many it require? Because K shell have the capacity of 2 electrons, it can attain 2 electrons. Okay, so in hydrogen only 1 electron is there, so how many electron it need? 1 electron it needs. Okay, so to fill the K shell it needs 1 electron. So two hydrogen atoms share the electron to form a molecule of hydrogen, and this allows each hydrogen to attain electronic configuration of the nearest noble gas, that is helium. Okay, that is helium, when which 2 electrons in its K cell it has. So we can depict this using the dots or crosses to present the electrons, valence electrons. So that's why we need to follow this one to show the sharing of electrons. So we have hydrogen here, okay, and this having the cross, and another hydrogen. These are the valence electrons. Cross means valence electron. You can write here valence electrons. Okay, now when they share, okay, just look at the diagram, you will understand. When they share, okay, so these crosses will together, they are sharing the electrons and they are becoming H2 molecule. Here it is, they are having the atoms, and here they becomes molecule by sharing electron. In this way we will see one by one for the molecule of oxygen and for molecule of nitrogen and for the carbon.